Hello, and welcome back to this ElasticSearch tutorial. In this part, we'll review the document APIs that are available to us within ElasticSearch to search, index, modify, and delete documents from within our index. The first thing you need to know is that every record or tuple, as you would call them in a relational database, are called documents in Elasticsearch. You might be familiar with the term if you're familiar with other NoSQL databases such as MongoDB. So everything that you do in Elasticsearch modifies or retrieves a document. Like we mentioned in a previous video, everything that you do in Elasticsearch is done via a REST API. Those REST APIs can either deal with a single document, such as the index, get, delete, and update APIs, or they can deal with multiple documents such as multi-get, bulk, delete by query, update by query, and reindex. The names are pretty self-explanatory, but let's run by them just to see what each means. Index is used to index a new document, that is, to insert a new document into our Elasticsearch index. Get is used to retrieve a document. So this is what you would use when actually searching for documents whenever a person uses the search box on your website, for example. That would be a query call to the get API. Delete deletes a document from your index, and update updates a document from your index. Multi-get is used to retrieve several documents at the same time. Delete by query is used to delete several documents that match a query. Update by query is used to update by a query. Those two work very similarly to having an update or delete statement in an SQL database with a where clause specified. Whereas update and delete are the same as having an SQL query where the where is an ID or a primary key, so that they will always affect only one record. Bulk is used to perform many index or delete operations in one call. This makes it so that your call is faster than if you made a single call for each of those operations. And then Reindex just copies a document from one source index to another. In Elasticsearch, you create indexes, which are collections of documents, similar to how tables or databases work in a relational database. So whenever you call one of these APIs, you'd have to specify, besides the parameters for each call, the index that you want to work on. Let's see an example. First thing that we're gonna do is that we're gonna fill our index with information. We're gonna use curl still to fill this information, but don't worry, we'll learn of easier ways of interacting with Elasticsearch soon enough. Now, this is the same as we did earlier in another video for checking the health of our search engine. However, whereas before we used _cat, which was just a generic catalog for Elasticsearch, in this case we're gonna have to specify an index name, and we're gonna call it test. Then we call the Document API, and we need to input an ID for our document. We're gonna input a very simple document with just a username, and it's gonna be called Tom. Now, I know this is a bit hard to read, but let's see what we did here. We used a put request to localhost/test, which is our index, /document, because we want to call the document API, and we passed a JSON document which was just one field, user Tom. This retrieves a response that says that the result was that index was created and one was successful. So our document was indexed successfully. Next, let's see if this was actually indexed successfully. We'll use the browser for that. Similarly to before, we're gonna call the index that we're using, test. We're gonna call the document API, and we're gonna call the ID that we just inserted. By default, what a browser does when you enter an address here is a GET call. So this is the same as doing a GET call from curl. As you can see, first we have the information associated with this record. We get the index, we get that this is a document, we get the ID, the version, and then we have the source. The source is the document that we actually indexed into Elasticsearch. In this case, a JSON document with just a key value pair, user and name, this being user and Tom. However, if we did everything via curl, this would get tedious very fast. In real-world applications, you would not use curl for something like this, or if you would, it would be done programmatically, so this would be automated and you would have no issues. However, when developing or when testing, you might want to have a different tool to do this. We're gonna use a tool called Postman, which is used for making HTTP requests. Since ElasticSearch does everything via REST API, which are HTTP requests, then this is perfect for our purposes. Let's try and input another document into our index and see how this goes. First, we select that this is a put request. Then, we use the IP address for our index for our ElasticSearch instance. We use the same index as we did for the other document because we want everything to be in the same index. We use the Document API, and now we're using the ID too. Then underneath, you would go to Body, select Raw, and select that this is a JSON document that we're posting. And here, I've typed out a longer JSON document. In this case, I have a user, Victor. I have a video date, which is 2019, July 16th, and I have a description. Let's send this and see what we get. Here at the bottom, you'll get the response, in this case, a JSON document. And for all ElasticSearch requests, you would get a JSON document detailing whether your request was successful and what actually changed. This is the same one that we just saw. It says our index is test. It's a document, it's an ID number 2. Version of the document is number 1 because we just created it. And the result was that it was created successfully. Now, let's retrieve this document, or the one we created earlier, from this interface. Just as we did via the browser, we input the ElasticSearch instance IP address, then the index, then specify that we're using the Document API, and then the ID for the document. And if we retrieve this, we'll get that our user is Tom, and if we do the second ID, then we get the other document that we just indexed. So just with these two commands, you already have a functional index to search. One thing that you might have noticed, if you're coming from a relational database background, is that the documents that we stored here don't have the same fields like you would need if this were a relational table. That is because the documents in an index can be whatever you want them to be. Although, generally, you tend to store similar documents in the same index to make it easier to search for afterwards. Then we have the other two single document APIs, update and delete. Let's give those a whirl. Update can be done with two different ways. One is to use a script which allows you to do more complicated conditions, and the other is to send a partial document. Which lets you send a document fragment just as if you were indexing a document from scratch and using that to update the existing document. Let's see what we mean. First, we're gonna update our first record. So we're using a post request, the IP address for our Elasticsearch instance, the index, and now we're using the update API, and then the ID for the document that we want to update. In this case, it's number 1, Tom. Then the JSON that we sent for this request is a document. Everything that comes within the document key is going to be either inserted or replaced within our existing document. If the document already has an age key, then that value will be updated, and if it doesn't, it will be created. Our number 1 document doesn't have anything right now other than user, so this will add a new key called age, and it's going to be set as 31. Let's try it. Just like when we inserted the document, we get a response specifying the index, the type, the result updated, how many were successful, and other useful information. You can see here that version changed to 2 because we just updated the document. And if we do the query again to search for this document, you can now see that the user has an age, 31. The other way to update a document is via a script. This script uses the script parameter rather than document, followed by a script to modify our document. In this case, we're doing a simple one. We're just setting the age to 30. Let's try it. Once again, we get the result that updated. We get that 1 was successful because we were only updating a single document, and we see that version is now up to 3. And let's see that this actually changed. As you can see here, the age is now 30. The difference between these two is that this one, when you update via a script, you can do some more complicated stuff. For example, let's add 5 years to the age. You can see that version is now 4. and you can see that age is now 35. You can use this in order to make more complicated updates to your information depending on other information on your index or from outside. Then finally, we have the delete document API. For this, we'll use the same address that we used to create a document and to retrieve a document. The difference between the three is only what type of HTTP request you use, whether it's a POT, a GET, or in the case that you want to delete a document, you would use a delete HTTP request. So let's delete the TOM document, ID1. Here you get the information of the document that you just deleted. You can see that version was 5, result was that it was successfully deleted. And if we try to search again, we get something different. It says found false, which means that this was not found. Finally, we have the multi-document APIs. These ones work very similarly to what we just saw, but they retrieve or update or delete several documents at once, rather than just one. Let's insert another document, and it's gonna be ID1 again, and we're gonna call it Tom, and we'll leave this as it is, just so that we have two documents to get. In this case, we're not gonna use the doc API endpoint anymore. We're gonna use mget for multi-get. And for the body, we're gonna send a JSON document like we've been doing. Let's search. Actually, I left this blank. Okay, so let's see what we just did. I'm sending a request to the multi-get API endpoint, and I'm specifying that I want this array of documents. I want the document with ID1 from the test index and the document with ID2 from the test index. And my response down here is that I get the Tom document and I get the Victor document. So this allows you to retrieve several documents at the same time. If you want to do this in a different way. And instead of having to specify the index on each document on the body for the request, for example, if you're checking for all documents from the same index, then you can remove this line and because we're already specifying the index here, this works the same. However, if you want to get documents from different indexes, then you can remove this here and specify the index on the document body. Same thing for documents. If you only want to specify the IDs, because everything that you're getting are documents, then you can just specify the document on the URL. This is useful if you were to make a longer query, such as this, where you don't want to specify the index and document type for each one. In this case, we get a result as if we made each of those queries individually. For IDs 1 and 2, we get the document, and for IDs 3, 4, and 5, since we don't have them on our index, we just get found false. Finally, the other API endpoints are used, like I mentioned, to bulk requests, to delete by query, which works very similarly to the update by query. Let's see an example. In this case, we're going to make a post request. We're going to use the update by query endpoint and we just call this without any body. Then you can see that we already updated our two documents. If I search for one of my documents, you can see that version is 2, even though we didn't actually make any change. Making an update like this is useful when you change the metadata for Elasticsearch and you want those changes or the mappings to update. But we can also actually change the documents by using a query. And don't worry if the terminology for a query is not familiar with you. We'll see that in the following video. Just know that here we're specifying a query for username Tom. And you can see that right now Tom is version 2 and Victor is also version 2. But if we run this query, instead of having both update For example, if we run a query by vector, we can see that 1 was updated. And if we go back here, you can see that Tom is still version 2, whereas Victor is now version 3. So this query works similarly to a where from a relational database. And we can specify a script here, for example, let's actually just copy the script that we already had. To add an age to this document. This is gonna give us an error if we don't do this, because Victor doesn't already have an age, so we can add to it. But let's run this, and you can see that one document was updated. And if we update this, you can see that age is now 30. And you would use a very similar syntax. We're just going to replace this update for delete, and if I run this, the document with user Victor is going to be deleted. You can see here that one document was deleted. And if I try to search for this document, I'm going to get a message that it was not found. So the delete by query is the same as update by query. You just change the address for the API and send only the query. There's no need to send a script. So that's it for this video. Hope you learned something, and see you in the next video. In the next video, we'll learn how to index documents using Logstash, which allows you to bypass the document API and automate the ingesting process to make it easier.